Somewhere in a research lab far from any launch pad, two scientists have just written down a sentence that sounds like it belongs in a science fiction screenplay, not a peer-reviewed academic journal. They've proposed that before humanity brings home a single gram of Martian soil, a single speck of lunar dust, a single fragment of an asteroid, that material should be locked away. Not in a lab in Houston, not in a clean room in Tokyo, but on the surface of the moon itself. Their reasoning is simple, and it is unsettling. We may be about to bring something back from space that we do not understand, cannot predict, and might not be able to stop. This isn't a conspiracy theory. It isn't a movie pitch. It's a real proposal, published in the summer of 2026 in a respected scientific journal called Ambio, written by two researchers who have spent their careers thinking about exactly this kind of risk. The risk of something small, invisible, and completely unknown crossing a boundary it was never supposed to cross. To understand why two serious scientists would suggest something this dramatic, you first need to understand what's actually happening in space exploration right now, in this exact moment. For the first time in human history, we are not just visiting other worlds, we are actively planning to bring pieces of them home. NASA's Perseverance rover has already spent years on Mars, carefully drilling into rock, sealing samples into sterile titanium tubes, and caching them on the Martian surface, all in preparation for a future mission that will scoop them up and fly them back to Earth. China has already pulled off a lunar sample return, bringing back material from the moon's far side. Missions are in progress, or being planned to grab material from asteroids, from the icy moons of Jupiter and Saturn, from anywhere in the solar system that might, just might, hold a clue about whether life exists, or ever existed, beyond our own planet. And that's precisely the point these researchers are raising the alarm about. Because if there's even a small chance that any of these places harbor some form of life, however microscopic, however seemingly harmless, then every single sample return mission we launch is also, potentially, an invitation. An invitation for something that has never encountered Earth's biology, Earth's immune systems, Earth's ecosystems, to arrive here for the very first time, with absolutely no natural predators, no evolutionary history with anything on this planet, and no way for us to predict how it might behave. If that sounds abstract, consider something that has already happened. Not on Mars, not on the Moon, but in low Earth orbit aboard the International Space Station. Researchers have identified strains of a bacterium called Enterobacter buginensis living inside the station that have measurably changed from their Earth-based relatives, mutating, adapting, becoming what scientists describe as genetically and functionally distinct from the populations they came from. This happened after just a few years in the unique environment of a space station, unusual radiation levels, microgravity, a sealed artificial habitat. Now imagine that same process playing out over months or years on the surface of Mars, in an environment humans have never truly test-driven biology in at all. A microorganism could leave Earth relatively ordinary and come back different, not necessarily alien in origin at all, but altered by an alien environment into something Earth's biosphere has never seen before. The researchers behind this new proposal even have a term for this exact scenario. They call it back contamination, or more specifically, sequential forward and back contamination. Earth life going out, changing out there, and coming home as something new. And that's actually the less exotic possibility. The more direct concern, the one that captures the imagination and probably kept these two scientists up at night while writing their paper, is what happens if we find something that didn't originate on Earth at all, something indigenous to Mars, something that evolved in the ice of an outer moon. Nothing has ever been found. Let's be completely clear about that up front, because it matters. No mission has ever detected confirmed extraterrestrial life, microbial or otherwise. This entire proposal is built not on evidence that alien life exists, but on a much more careful kind of reasoning, the precautionary principle. In other words, the researchers aren't saying, we know something dangerous is out there. They're saying, we don't know what's out there. The stakes of being wrong are potentially civilization altering, and our current safety plans simply are not good enough to handle that uncertainty. To make their case, they turn to something we do understand extremely well here on Earth, the history of invasive species. Anyone familiar with ecology knows the pattern. An organism, a plant, an insect, a fish, a fungus, gets moved from the ecosystem it evolved into a completely new one, often by accident, often through nothing more dramatic than a ship's ballast water or a piece of packing material. And once it arrives up somewhere with no natural checks on its population, no predators calibrated to control it, no competitors adapted to outcompete it, that organism can spread explosively, reshape entire ecosystems, and in some cases cause damage that persists for centuries. One of the paper's authors, a biology professor who specializes in exactly this kind of invasive species research, argues that this pattern is the single best model we have for thinking about what might happen if extraterrestrial biology ever reached Earth's biosphere completely unchecked. If an ant or a beetle can devastate an ecosystem after crossing an ocean, What might something truly alien do after crossing tens of millions of miles of empty space, arriving on a planet where absolutely nothing, not bacteria, not fungi, not immune systems, not antibodies, has ever had the chance to evolve any kind of defense against it? This is where the moon enters the story, and where the proposal stops being purely theoretical and starts becoming an actual piece of space policy. The two researchers argue that instead of shipping every sample straight to Earth, which is how nearly every past mission has worked, future sample return missions should route through an intermediate stop, a dedicated secure biocontainment facility built on the lunar surface. Not a research base with scientists living inside it in this scenario, but a highly controlled, mostly automated laboratory, operated almost entirely through advanced robotics, where incoming material could be examined, tested, and if necessary, safely contained, all without ever touching Earth's atmosphere or Earth's biosphere. The logic behind choosing the moon specifically is worth sitting with for a moment because it isn't arbitrary. The moon is close enough that it's realistically reachable with current and near-future spacecraft, and it's already the destination for NASA's planned permanent lunar base, meaning the infrastructure to support such a facility may already be under construction for entirely separate reasons. But more importantly, the moon, as far as we can tell, has no biosphere of its own to contaminate or be contaminated by. It's not just distant from Earth, it's naturally sterile in a way that almost nowhere else humans could easily reach actually is. If something did go wrong inside a lunar quarantine facility, if containment somehow failed, the damage would be isolated on a dead, airless world, roughly 238,000 miles away from every living thing we know of. That distance wouldn't just be a formality. It would buy something invaluable: time. Time for scientists on Earth to study what happened, understand the danger, and figure out a response, all without a single organism ever having the chance to reach Earth's ecosystems in the meantime. One of the researchers put it in especially stark terms when describing why current safety measures fall short. No facility that exists on Earth today, he argues, can honestly guarantee complete containment, elimination, or control of an unknown organism if something went wrong during an accident. Every biosafety lab on this planet, no matter how advanced, is still on this planet, connected, however indirectly, to the same air, water, soil, and living systems that a truly novel organism could eventually reach if containment ever failed. A facility on the moon removes that connection entirely. It creates something close to a genuine firewall, a hard physical barrier of empty space and vacuum between Earth's biosphere and anything potentially dangerous returning from beyond it. It's worth pausing here to address the question, probably already forming in your mind: is this really necessary? Are we overreacting to a threat that might not even exist? The researchers themselves would likely say that's exactly the wrong way to frame the question. Their point isn't that alien contamination is likely. It's that the consequences, if it happened and we were unprepared, could be so severe, so irreversible, that even a small probability is worth taking seriously. This is the same kind of thinking that underlies why we build earthquake-resistant buildings in regions that might only experience a major quake once every few centuries, or why we stockpile vaccines against diseases that haven't caused an outbreak in decades. You don't wait for the catastrophe to prove itself before you prepare for it, because by the time it happens, in this scenario, it may already be too late to contain. And there's a second layer to this story that makes it even more urgent, according to the paper's authors: timing. This isn't a hypothetical concern for some distant future decade. Sample return missions are happening right now, and more are being actively planned by multiple countries and even private companies, all racing toward increasingly ambitious targets across the solar system. NASA's Mars sample return effort has been years in the making. China has already demonstrated it can bring lunar material home and has ambitions stretching toward Mars sample return of its own. Space agencies and private companies alike are pushing further and faster than ever before. And according to the researchers, none of the missions currently being planned around the world have actually laid out a serious, workable plan for handling the specific risk of returning biological material safely. In other words, we are already racing toward the moment when this stops being theoretical, and the safety net the researchers are describing simply does not exist yet. So what would actually happen inside a facility like this if NASA or another space agency ever decided to build one? Picture an incoming spacecraft, arriving not on a trajectory toward Earth, but toward a landing site somewhere on the lunar surface. Instead of human hands ever touching the sample containers, everything from that point forward would be handled by robotic systems, specifically designed to eliminate the possibility of human exposure or accidental release. Sealed sample tubes would be transferred, scanned, and tested using instruments built to detect any sign of biological activity, metabolic signatures, anything that might indicate the presence of life, dormant or otherwise. If everything came back clean, material could eventually be cleared for transport to Earth under established protocols. If something raised concerns, the facility itself would serve as the container of last resort. a place where an unknown organism could be studied, understood, and, if necessary, kept indefinitely, without a single Earth-bound ecosystem ever having been exposed. This isn't actually the first time someone has floated an idea like this. Decades ago, in the early years of the space age, NASA itself commissioned a study exploring almost exactly this same problem. What do you do with material returned from another world if you can't be completely certain it's safe? That early study never went anywhere, largely because the missions capable of returning meaningful samples from deep space simply didn't exist yet. But the core question it raised was never actually answered. It was simply shelved, waiting for exactly this moment. A moment when sample return missions have gone from science fiction to scheduled spacecraft. What makes this story so compelling and honestly so unsettling in the best possible way is that it sits at this rare intersection of two things that don't usually overlap: rigorous, credentialed, peer-reviewed science, and a premise that sounds like it was ripped straight out of a big-budget thriller. These aren't fringe theorists chasing conspiracy. This is a biology professor who has spent his career studying invasive species and a strategic risk analyst publishing in a respected international journal, making a calculated, careful argument that humanity's excitement about finding life beyond Earth may be outpacing our preparation for what happens if we actually succeed. And maybe that's the most striking part of this entire story. For all of human history, the search for life beyond Earth has been framed almost entirely as a triumph waiting to happen. The moment we've all been waiting for, the discovery that would change everything we understand about our place in the universe. Nobody talks much about what happens in the hours, days, and years after that discovery. What do you do with the evidence? How do you bring it home safely? What if the answer to, are we alone, turns out to be, yes, we are not alone, and that answer arrives not as a signal from a distant star, but as an invisible passenger, sealed inside a titanium tube, riding home on a spacecraft that was never designed to ask permission first? The scientists behind this proposal aren't trying to scare anyone away from exploring the solar system. If anything, they're trying to make sure that exploration can continue safely, that the extraordinary scientific achievement of finding life somewhere else doesn't accidentally become the very thing that puts life here at risk. Their message, at its core, is almost deceptively simple. Before we open the door and let something in, we should probably make absolutely sure we understand exactly what's standing on the other side. And for now, at least, according to this new research, the safest place to find that out might not be a laboratory anywhere on Earth at all. It might be 238,000 miles away, on the dead, silent, airless surface of the moon.